In this video, we're going to look at composite functions. So composite functions, what I like to think of as a function inside a function. So that's when you have such as fx is equal to x squared, and then this x is referring to here x. But what we can do is we can replace x with something else. So for example, when we say f1, that means 1 squared, so it equal 1. f2 is equal to 2 squared, so it's equal to 4. But rather than replacing a number, what we can do is we can replace this x with another function. So we can go f gx is equal to gx squared. So let's say gx is equal to x plus 3. Then that means f of gx is equal to x plus 3 squared. So effectively what we've done here is we've got the gx and we've replaced x with gx. And so that's what composite functions are referring to. But it's like function inside a function, or when you have f gx, or another notation for this would be f of fg, or otherwise known as like fog or gof, and that's just the other way around. So g of f, so it's g fx, like that. However, it's the same thing. You're replacing x, but now you're replacing x with fx. So you just have to be careful of what order it is. So looking at an example, so fx is equal to 1 over x minus 3, and then gx is equal to root x. And so we'll look at f of g of x. So subbing these values in, we get fx, and then we have to replace x with gx. So what we find is we get 1 over gx minus 3, which is equal to 1 over the square root of x minus 3. If it was the other way around, so if we looked at g of fx, then we replace x with fx, and that means we would get the square root of 1 over x minus 3. So that's equal to that. Now, this is actually not defined, because let's say x is equal to -4. That would give us 1 over -7. You can't have a square root of a negative number, so you would have to restrict the domain. So in this video, we're not going to look at how you can restrict the domain. We're just going to, if they don't say restrict, you have to work out if the composite function exists. So we could say that this function here is equal to this, and it does exist. And then this function here is equal to there, but it doesn't exist because for some of the x values, the function doesn't exist, and we haven't restricted the x yet. So looking at f of g of x. Well, firstly, looking at the domain. So the domain has to be a subset of the domain of gx. And the reason for this is because if gx is, let's say, equal to square root x, then x has to be greater or equal to 0. So you can't have x is equal to -2, because no matter what the function f is, if gx is not defined, then f of gx, or the fog, will also not be defined. So it can also be equal, so this domain could be x is just greater or equal to 0, but it may also be less than, so it could be a smaller set. And then we'll talk about that in a second. But firstly, just understand that the domain you can't have numbers that are not defined of gx. So if gx is not defined when x is equal to 3, then f of gx is also not defined when x is equal to 3, no matter what f is. We also have to look at another part of the function. So now that was talking about sort of the gx, but what about fx? Because fx may have a restriction itself. So fx may have a restriction. So looking at the domain of fx, then the domain of fx has to relate to the range of gx. And the reason for this is that the domain of fx is in reference to x. However, now we've replaced x with gx. So when before we looked at like fx, we looked at, let's say, f negative 2, f3. And so that's when just x is equal to negative 2, x is equal to 3. But rather, when we look at f gx now, when we say f is negative 2, what that means is gx is equal to negative 2. When we say f3, that's saying that gx is equal to 3. So instead of looking at x, now we're looking at gx. And when gx is equal to something, that is referring to sort of the y value, or we're looking at the range. So if we had the equation gx is equal to x squared and fx is equal to the square root of x. So firstly, what's the domain of gx? Well, x can be any real number. So that doesn't restrict the domain at all. But now we have to look at the next restriction. So what about fx? Well, we can see here that here is x has to be greater or equal to 0. So that's the domain restriction of fx. But that has to relate, instead of relating to x now, that relates to the range of g. So that means f of gx is like that. So gx has to be greater or equal to 0. Now that actually is the case for x squared, because gx is always greater or equal to 0. So that means that that's fine. So this composite function is defined as the range of gx is a subset of the domain of fx. So if it was the other way around and the range exceeded, so let's say gx could equal negative 2, it wouldn't be defined, because if gx equaled negative 2, then it would get the square root of negative 2, which is not defined. So as this is the case, then the domain of f gx is actually equal can be all real numbers. That may not be intuitive at first, because you think, well, root x. But you have to remember that x has now been replaced by x squared. So when x is now being replaced by x squared, then x can be any number, because x squared is just going to be a positive number, and the square root of any positive number is defined. So a good way of representing this and checking your answers is to draw a table. We have fx, gx, and you have the domain and the range. So looking at the domain of fx, that is all real numbers apart from negative 3. And then the range is going to be all real numbers apart from 0. Then the domain of gx will be all positive values, including 0. And then all the positive values are including 0. Now, if we want to check if f of gx is defined, so it's very important sort of which order it is. And that's because, as I was talking about before, the domain and range it's talking about the domain of x and then the range of gx. So firstly, we can see, well, what's the domain of gx? Well, r plus, and then including 0. So firstly, we know that the domain is going to have to be a subset of this. So we can't have any negative x values. So x cannot be, well, it can be equal. So x cannot be less than 0. But for the moment, that doesn't really matter, because we're just checking if it's defined or not. And that's a natural x restriction, which we've already talked about. So what we need to look for is we need to look for the range of gx. We need to see if the range of gx is a subset of the domain of f. So the domain of f and the range of g. So if we look at the domain of f, we have all r values apart from negative 3. If we look at the range of gx, we find that it's all positive r values, including 0. Now, the range is a subset of the domain because all of these values are encompassed in the domain of fx. The only value it can't be is -3. And -3 is not part of r plus 0. So that means f of gx is defined. So what about g of fx? So if we have g of fx, so that means that the range of fx now has to be a subset of the domain of g. So if you look at this, we have the domain of g is here, and then the range of fx is here. And so without a restriction, this is not defined. So not defined. And the reason for this is because it is not a subset. Even though some of the values are included in both, with the range it includes negative values. For example, let's say -4. So -4 is included in the range of this. However, -4 is not included in that set. So that means it's not going to, this value here is not a subset of this value here. Another example is looking at 0. This does not, so it's fine that it doesn't include 0, but if we can find values here that are included that aren't included there, then that means it's not a subset. So it's important about looking at which one we're looking at. We have to look at the domain, and we have to make sure that, and then look at the range. We have to make sure that all the range values are encompassed in this domain. So as we can see, -4 is not. Looking at this numerically, if we put f -4, then that means 1 over -4 plus 3. If fx is equal to 1 and x plus 3, so that can equal -4. And then that means x would have to be, let's say like -3 would make it 0. So -3.25, that would give 1 over -1/4, which would just give us -4. So if that's the case, if x is equal to that number, so that means the range of fx, -4 is included in it. But once we sub -4 in, so we have g of fx, so fx is equal to -4, so g of -4 is equal to the square root of -4, which is not defined. So without a restriction, this composite function is not defined for g of fx, but we've shown for the other way that f gx is defined. So after this video, you should be able to know what composite functions are, understand how you can sub in the different equations, be able to set this up, and then work out if they are defined, and note the difference between g of fx and f of gx.